Welcome back to the PLC Professor's video library. The PLC Professor presents How to Program a PLC, Volume 1, Part 0, or the Introduction. And this is supported by the Complete PLC Learn series and the PLCprofessor.com website, as well as the PLC Professor YouTube channel. We intend to produce several of these application videos, beginning with this one. Everyone is familiar with the idea of versions, so we'll just call this V 1.0. It could be version 1.0, volume 1, part 0, whatever you like. However, we do need to, since this is an application video, we need to start with an application. And we're going to start with as simple an application as we can think of. The one that comes to mind is a garage door opener. Everybody can visualize a garage door opener. However, if you're from a part of the world where you don't use garage doors, you have gates, then instead of running a garage door up and down vertically with electric motor, you could run a gate horizontally back and forth. So we start out with a simple application. And this is what a garage door opener looks like in the United States and probably most other countries in the world. You've got a garage door, and you notice that door has hinged sections. So if you look at that door closely, you'll see it's in 4 horizontal sections. If you look real close, you can see the hinges. So as this door is pulled upward into that track and rotates, if you want to say rotates, or folds towards the ceiling and then, until it lays flat against the ceiling. If you've never seen one of these operate, go online, you can find a video that shows a garage door opening. We begin with the garage door, and of course it has to have side rails, so that what looks like a white track is really probably galvanized steel, and the wheels on the edges of the garage door sections following that track to guide it upwards and parallel with the ceiling. And of course this door is not light, very heavy. So to avoid using an expensive, powerful motor, plus keep in mind that if for whatever reason the electricity fails or the motor fails, you still need to get your garage door open and closed. If you look at the center of the garage door towards the top, you'll see a rope hanging from the mechanism with a red handle. That's so you can pull on that and disengage the garage door from the motor. However, that still doesn't deal with the fact that that garage door is very heavy and you would not be able to lift it and push it up into those tracks. So you need a counterbalance. The counterbalance is that long horizontal rod, and there are 2 torsion springs. Those would be coil springs that are held stationary at one point, and then when the garage door is pulled up, the rod rotates and exercises tension. Now, the tension has to be already in the spring when you close the door, meaning that with the garage door in the full open position, you lock down the torsion bar. Then as you lower the garage door, it builds up tension in the spring. That way, when you want to lift the garage door, the tension that's built up in the spring helps you lift the garage door. And we also need a mechanism for the electric motor to pull the door upwards and lower it. And so this additional track, a center track, and the lever that attaches to the garage door and is pulled by a chain on the motor. And then of course there is the electric motor, a reversible electric motor. In these modern times, safety of course is a big issue, especially in the United States where OSHA rules. So what can we add to make this residential device safer around children? Anyone that's dealt with a modern garage door opener knows there's a safety photo eye that is a through beam type photoelectric device that detects anything that is blocking the door from closing. And you want the beam high enough so if a person happened to be, sitting there, or kind of half laying down, the beam would still be blocked and the garage door would not come down on the person. Now, you would not use a PLC to control a residential garage door. You would not even build your own control for a residential garage door. However, and by the way, we also need push buttons to operate this thing. So there's your whole garage door opener, including safety device and push buttons. So this is more what an industrial garage door might look like, outside and inside. And the push buttons that you would use to operate it. Now, if you look at that garage door, you'll see that it goes up and down, but it doesn't actually fold into a horizontal position. It just goes up and down. But you see the counterbalance device there, the horizontal rod right above the garage door, and the two heavier black objects. Those are the torsion springs. And of course, there's open, close, and stop. So this is more of an industrial application. So look at the diagram here. Look at the whole thing in graphical form. We have a reversible electric motor, a limit switch to prevent over travel past the full open position when the garage door is pulled all the way up and travels down towards the motor. When it hits that limit switch, it'll break continuity to stop the motor. And then we need another limit switch to stop the motor when the garage door is completely closed. We don't want to keep driving it into the ground. A safety full electric switch, a push button station as the operator interface, and we have a single push button station as an alternative. So we have a choice of these two operator stations, up, down, and stop, or we use the alternative single push button, which we probably would not do that with an electrical design, but we could with a PLC. And primarily the way a single push button works is this. The two limit switches tell us if it's all the way up or all the way down. And then, of course, the photo eye tells if there's something blocking it. But the point is, if it's all the way up and you have actuated 2 LS, limit switch 2 up there, and you push that button, then it's basically you're saying you want the garage door to go down. If the garage door is on its way down or up, and neither limit switch is actuated, and you push the button, it assumes you want to stop. So if it's traveling, you push stop, you push the button again, 1 PB, it stops, you push it again, it goes the opposite direction. That's not the direction you want. You push the button again, it stops, push the button again, it goes the other direction. So you can use a one button as an alternative. Now we're going to begin this application by discussing the basics of electrical design to make sure that all the viewers understand the process and the symbology that we're going to use. Again, as I mentioned earlier, if at this point you're not following what we're talking about, then you need to pause or stop this video and then go watch the one on basic electricity and then come back and watch this one again. All industrial circuits start out with 2 poles of electricity, positive and negative, L1, L2, and you could call these L1 and L2 if you want, because we are going to be working with 115 volts AC, because that's the power form that you would use in a residence for a garage door. And you could call these, like I said, L1 and L2 if you like. And we are going to build our circuits between these two. If you like, you can think of these two conductors as the 2 prongs on the plug that you plug in an outlet, L1 and L2. Okay, we're going to start with a reversible electric motor, and a reversible electric motor has 3 leads, 3 conductors coming out of it, forward, reverse, and a common lead. Now, in the industrial world, we wouldn't show this as a motor with 3 leads on it. Instead, we would show 2 motor starters or 2 contactors that control forward and reverse. So this forward and reverse or reversible motor, we're going to show it as 2 separate circuits, one for forward, one for reverse. But we have a dashed line around it to show that it's actually one device. It's really just one electric motor represented by 2 solenoid coils that control the switching of the direction. So we show several connections here. These 2 connections here are the common, but they are common to both directions of the motor. So really it represents one path of conduction, the common for the motor. We have a connection for forward and another one for reverse. To control this motor, we need to complete the circuit through a switch. So we add in a switch, and this switch is a single pole, double throw, center off switch. In one position, current flows through the forward circuit. In the opposite position, current flows through the reverse circuit, and then back to the center position if we don't want the motor energized. Now, this would obviously run the garage door up and down, but would not be what I would call a user-friendly control system for many reasons, which you will see. This arrangement is actually worse, but at least we're going in the right direction. This is worse because the motor is always running in one direction or the other. If you look right now, the relay is de-energized, so the normally closed contact passes current flow from the pole on the left through the motor to the pole on the right. If you close the switch, contact relay, CR, energizes, it opens the normally closed and closes the normally open, and now the motor's going the forward direction. So no matter what you did with this switch, it's going to be going up or down. So that's not going to work. So we add a momentary push button into the circuit, and the other switch, not the momentary push button, but the other switch becomes a direction selector, and the push button actually initiates the door motion. This arrangement allows us to select a direction, and for this reason we call it a selector switch. How else might we accomplish the same level of control other than what we have here? Remember that if the switch is open and you push the button, it goes reverse. If the switch is closed, you push the button, it goes forward. How else might we do this? Well, we could have a separate push button for each direction. One for forward, one for reverse. But what happens if you push both buttons simultaneously, which some people are bound to do just for grins or kids doing fooling around? Well, if you push both buttons simultaneously, you feed power to both sides of the motor, but the motor is stalled because the 2 directions are fighting each other, and you tend to let the smoke out of the motor. And once you let the smoke out, it's impossible to get the smoke back in. In other words, you're going to burn the motor up or damage the motor. So how might we modify the push buttons to prevent this from happening? We use interlocking push buttons. Now there's only 2 push buttons there, but each push button has 2 sets of contacts. Each has a normally open and a normally closed. Right now, the first switch, the upper contact is open, the lower is closed, and just the opposite on the second one. So if you were to push both buttons together, then both circuits would still be open. But if you push just one, then you'll go forward, or just the other, you'll go reverse. If you don't push any, you don't get anything. So these are interlocking push buttons. So by pushing one, you're disabling the other from doing anything. Now, again, this would work, but you would have to stand there and hold the button to get the motor to run the garage door all the way up or all the way down. So now we go to something called seal-in logic. Okay, with seal-in logic, the idea is you push a button and a relay energizes, then one of the relay's contacts bypasses the push button, so you can let go of the push button, but the motor keeps on going. Now this means the motor cannot be energized in the forward circuit until the door has been moved away from the switch. So we're going to add a limit switch. We're going to throw that in right now. And this limit switch is there to prevent the motor from continuing to pull the garage door in the forward or up direction after it's reached the end of travel. So when the garage door gets all the way up, it hits this switch, opens the circuit, and it won't travel any further. Now the start circuit down below, it's still energized. One CR is still energized and one CR contact is still closed, but the limit switch is open, so it won't go any farther forward. Now of course, it's all the way up. How are you going to get it down? But before we do that, let's go through this sequence again. You push the forward button, you energize one CR, the two normally open contacts for one CR, one of them provides current to the motor forward, the other bypasses the push button, so you can let go of the button and the motor will continue to run until it reaches the far up position. And this motor continues to run in the forward direction until one of two things occur. Either you press the stop button or it hits the limit switch. Either one will stop the motor. Keep in mind that if you hit the limit switch up above there, the motor stops running, but the circuit down below is still energized. You'd have to hit the stop button to de-energize that circuit. Duplicating the circuit for the reverse direction gives us a complete system. You know, up and down, forward, reverse. However, there are still many weaknesses in this design. And if you stop and think about it for a minute, you may see some of them. So if you want, you could pause the video here and think it through for a minute. And I'm going to keep on going, but if you pause it, when you come back, we'll be on to the next step. Okay. So here's what we have. The limit switches will prevent over travel by the motor, but you can still energize both sides of the motor simultaneously. If you look down below, if you push both the up button, that energizes one CR, press the down button, that energizes two CR, and that energizes both sides of the motor. Now if the motor is all the way down when you do that, it'll go up until it clears the limit switch, then there'll be power on both sides of the motor, and you'll probably burn the motor up. So what we're going to do is before we did interlocking push buttons, now we're going to use interlocking relay contacts. So notice that in the 1CR or up start circuit, we have a contact from 2CR, the down circuit. So if the down circuit is energized, then 2CR normally closed is open and you can't go up. Vice versa, if 1CR is energized, then the normally closed 1CR in the 2CR circuit is open and you can't energize 2CR. So instead of having interlocking push buttons, we have interlocking relay contacts. So you energize 1CR and it energizes the coil, energizes a contact, energizes the forward motor. Now I see I left out energizing the 1CR normally open in parallel with a push button. You just pretend it's there. But notice that the normally closed contact on the downside, it is now open, represented by blue or cold. So if you push the down button, you can't energize 2CR. Now, we don't want two stop buttons. See, we still got two stop buttons. So let's improve our circuit by making it one stop button. To do that, we just move it over into the head of the rung to make it a common condition, a common permissive for both relay circuits. So pushing that button will kill the power to 1CR or 2CR. It'll stop either up or down direction. There still remains a few more weaknesses in this design. We're going to leave it until later to actually discuss the changes. Now remember that we also mentioned a safety photo eye to stop the door if something is blocked. And before we put that safety photo eye in there, let's review one more time before we add the safety photo eye. These contacts are interlocking with the two relays to prevent you from turning both directions on at the same time. These two limit switches prevent over travel. Now we'll add in the safety photo eye. So the safety photo eye in this position would open either forward or reverse, up or down, if something was blocking. However, is this a good place to put the contacts? It will interrupt current flow to either side of the motor and motion will stop. But what will happen when the object or obstacle is removed from blocking the photo eye? Now, this is a through beam photo eye, and it's set to close the contacts when there's a through beam. In other words, when light goes all the way across the garage door opening, then these contacts are closed. So if it's clear because the light beam goes all the way across, they're both closed. So whether you're going up or down, it's not interfering. The instant something blocks the photo eye, these two contacts open and either direction is stopped. However, what happens if, say, a little kid walks through the beam that stops, but then he turns around and stands there and straddles the beam with his legs? It's going to come right on down and pop him on the head. So, in industrial circuits, you're not allowed to have any what's called unexpected motion. So you may be expecting it because you're the engineer and you designed it that way. But the operators are not expecting that door to continue coming down when you remove the obstacle. And everybody knows that owns one of these, just try to cheat it. Hit the button, run out the door real quick. If you break that beam at all, it stops and it sits right there until you start it again. So let's move the interruption of that photo eye to a slightly different place. Now, if we break that beam, this opens, this de-energizes both 1CR and 2CR, whichever one's energized, up or down. And of course, if you de-energize the up or the down circuit, in other words, you clear it out, then both 1CR and 2CR contacts are open and there's no motion up or down. And once you break that beam, in order to get this thing started again, you have to go push the up or the down button again. Okay, now let's move that photo eye one more time. And the reason that we want to move it here, and you just look at that for a minute and you tell me why you want to move it there. Well, we want to interrupt the motion if you're going down but not if you're going up. So if the garage door is going up and you happen to break the beam, so what? It's not coming down on you. So instead of breaking the circuit for both up and down, we put it so it only interrupts the down motion. There's another issue here, and that is if we if you press the up push button, the door will travel up until it hits the limit switch, and this looks good. But the open circuit is still energized until you press the stop push button to de-energize 1CR, which is preventing 2CR from energizing. So in this design, another weakness, if you push the up button, garage door goes up, it stops when it hits the limit switch, but 1CR is still energized. So you cannot de-energize 2CR with the bottom push button to get it to go down until you hit the stop button first, then press the down button. So we're going to put the limit switches in a different position. They'll still accomplish stopping the door from moving when they hit the end, but they will also clear or cancel the up-down commands. So there, we've moved the limit switches into a different position. I've also compacted the wiring diagram a little more towards the top of the sheet because we're going to need space for more logic because we're nowhere near done. So the change we just made was we want the limit switches to do more than just interrupt the current to the motor. We need the limit switches to cancel the up-down commands. Okay, what is another feature of our system that we haven't mentioned yet in the wiring diagram? That is the garage illumination. In other words, the light that comes on when you press the up or down button and stays on for a delay until you have time to get out of the garage or get in the house or whatever you want to do. So we're going to need a timer to create a delay. We're going to need an off delay timer, which I've added in here. The timer is initiated by either the up or down circuit and remains on for a program delay after both 1CR and 2CR are de-energized. So in other words, if you energize 1CR or 2CR, that will trigger 1T, the timer. And the contact 1T associated with timer 1T will turn on the light. And the light will stay on as long as the garage door is going up or down. Once the garage door is done going up or down, then 1CR and 2CR are both off. Both those contacts are open, and the timer no longer has a trigger. But because it has an off delay, the timer will hold its contact 1T closed for that delay period. And that keeps the light in the garage on long enough for you to get out of there. Okay, this concludes how to program a PLC Volume 1, Part 0, or the introduction. So we've gone over the electrical design of this application, and the next thing we want to do is go back and do the same thing but do it with a PLC. So thank you for watching. Go to the playlist or your disc, whichever you have, and continue with Volume 1, Part 1. Thank you.